Alright, we are now finishing up section 7.2. I'm on the bottom of page 6 in your notes. At the bottom of page 6, dealing with rational exponents, except now we're going to have them as radicals. So I am right here in the middle where it's talking about properties of rational exponents. All the product property here and the quotient property tell you is that you can split up two numbers if they're being multiplied underneath the same radical. And this would split into the nth root of A times the nth root of B. Vice versa, as with a couple of the other properties, you can go backwards with this too. Meaning, if you had something like the third root of 3 times the third root of 6, you can go backwards with this too and combine those under the same root. So it would be the third root of 18. So not only can you split them up, but you can also put them together. And it's the same thing, if I scroll down here, it's the same thing with the division. You can split them up into the nth root of A over the nth root of B, or as long as they're to the same root, you could also put them together. So let's use this information down here for some examples. Like if you had the third root of 4 times the third root of 16. This is not on my list under the third root. And remember the list that we made, if I go back a little ways, the list we made is down here. No, one more slide. Was here. This is the list I'm talking about. If we're looking for cube roots, I'm looking right here under this perfect cubes list. And 4 is not on that list anywhere, neither is 16. So since they are nowhere in this list, I can't simplify those. So what I'm going to do instead is I'm going to try to put them together first, then simplify. So I'm going to take 4 times 16, which is 64, and the cube root of 34 is on that list. It is 4. So I can put those together. Vice versa here, 162 and 2 are not on the fourth power list. If you go back to the list, they're not in that list anywhere. So I'm going to divide these first. So it ends up being the fourth root of 81. And that is on the list under fourth powers, and it is 3. The reason I can put these, the only reason that I can put those together, though, is make sure that these have to be the same. This fourth root and this fourth root. Same thing right here. I cannot simplify the fifth root of 16 or the fifth root of 2, so I'm going to put those together to be the fifth root of 32. And the fifth root of 32, if you check on your list again, is 2. Lastly, I'm going to combine these because they're both to the third root. 108 divided by 4, I believe, is 27. And the third root of 27 is on the list. It is 3. So we can split them up and we can put them together. Knowing that information, let's see what else we can do with these. A couple little warm-up exercises to make sure you know what I mean. This goes back to a few chapters ago, I believe chapter 4, dealing with radicals, where I take this radical 8 and I want to split this into radicals that I know, like the square root of 4, square root of 2, because if you look back on the list, the square root is a perfect square, and so we know it turns into 2 root 2. This we don't know, so it drops down. Square root of 80, do the same thing. I'm on the list, except now I'm under that perfect squares part. This can be split into 16 and 5. Square root of 16, square root of 5, and the square root of 16 is 4, so this turns into 4 root 5. And the last thing that we have done in the past is, remember, you cannot have a radical on the bottom. So we talked about how to get rid of this. We are going to take this times radical 5, because if you do something to the bottom, you have to do it to the top. Because on the bottom, root 5 times root 5 is root 25, which equals 5. So now the radical is gone from the bottom. And the top, I can't put those together. So I just leave it as 3 root 5 over 5. We are going to take this concept and we are going to apply it to now we're going to have cube roots and fourth roots and third roots and all that fun stuff. So let's take the same idea we did up here. I'm going to look at this number 48 and I'm going to try to split this into a couple of things that I know. Where am I going to get the things that I'm going to split it to? It's from the list. Go to the list and I'm under the fourth power, the fourth perfect fourths or whatever you want to call it. And I'm looking for any numbers in that list that will divide 48 evenly, like 16. The 4th root of 16, so I'm going to split this into 4th root of 16 and the 4th root of 3. Why did I split it like that? Because we know this 4th root of 16 will turn into 2, and this 4th root of 3 we don't know, so we leave it. Done. Same thing, same concept here, except now I'm looking in the third power in my notes. I'm looking for the perfect cubes, which I'm going to tell you right now will split into the cube root of 27 times the cube root of 2, because the cube root of 27 is 3, and I'm left with 3 cube root of 2. Done, because I can't split up the cube root of 2 anymore. And the last one, last example, before we get into adding and subtracting. I'm first going to split this into the cube root of 1 over the cube root of 9. The cube root of 1 is just 1, so that's nice. And I'm left with the cube root of 9 on the bottom. You cannot have a radical on the bottom. So we have to kind of go through the same process as we did up here to get rid of it. But I can tell you that your instincts will tell you to go here and multiply by the cube root of 9. And that is not correct. Here is how you figure out what you're going to multiply by. Let me put this on a new page. 1 over the cube root of 9. What I need to do is I need to multiply by something so that this cube root here, I'm going to multiply by that cube root of something, so that this 9 will turn into something that I know from the list. And if you look under the cubes on your list, the closest thing to 9 is 27. I'm going to turn this 9 into 27 because the cube root of 27 is 3, and now I don't have a radical on the bottom anymore. So how do I get 9 to be 27? I have to take it times the cube root of 3 over the cube root of 3. 1 times the cube root of 3 is the cube root of 3. 9 times the cube root of 3 right in here gives you 27. That turns into 3, and this will just follow it because you can't reduce. And now I have successfully taken the radical out of the denominator. So that is a way we can simplify these, as well as it's called rationalizing the denominator. You have to get this bottom number to be something from the list. So if this would have been the 4th root of 4, you would have been checking in the perfect fourths column and trying to turn this into something from that list. All right, the last thing we have to do are these 4 examples dealing with adding and subtracting. And then I will give you those checkpoint answers online. I want you to try those checkpoints as well. So let's take a look at adding and subtracting. Going back to your previous days in Algebra 1, hopefully you remember how to combine like terms. Like this 2xy plus this 3xy. This is having 2xy's plus 3xy's, which is 5xy's. You don't do anything crazy with these variables in the back part. Same concept here. I am not going to do anything with these radical 3's, but since they are the same, I have 2 of them plus 4 of them, which is 6 of them. So that will simplify to be 6 root 3, just adding the 2 plus the 4. This one is a little bit more difficult to see, but notice I have 5 to the 3/4, 5 to the 3/4. I have 3 of them here. I have 4 of them there. So if I have 3 of them plus 4 of them, I have 7 of them, whatever them was, which in this case was 5 to the 3/4. Last example, and then I'm going to have you try this checkpoint down at the bottom of the page. Last example, the only weird part here is that these are not the same. So don't be one of the people that combined these to be the 4th root of 68. No, that is not correct. You cannot put those together because they are not the same. Oh, you could multiply them. If this was multiplication, you could multiply them. But you can't add or subtract unless things are the same. So what I'm going to do is I'm going to try to break this 64 down using the rules that we had up here. I'm going to break 64 down and see if I can get it to be the same as this. Then I can put stuff together. So I'm going to go to my list, my perfect fourths, and I'm going to split this into the 4th root of 16 times the 4th root of 4. 16 times 4 is 64. The reason why I chose that is because that'll simplify down to 2 4th root of 4 plus the 4th root of 4. And if I have 2 of something plus there's technically a 1 out here, 1 of something, I'm left with 3 root 4. 3 to the 4th root of 4. Final answer. So in closing here, this and this have to be the same before you can add them. And it's going to be the same concept down here on the checkpoint. You have to get this and this to try to be the same before you can add them. I will put the answers to this checkpoint online. I want you to try those and check when you are done.